morning, students. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, in this session, I would like to explain application of principal stresses in designing of machine members. In mechanical components, the components are subjected to various loads like torsional loads, bending loads, tensile loads, and compressive loads. So, example, propeller shaft and seaplanes are subjected to direct tensile loads and compressive stresses and torsion loads. Due to this combination of all these stresses, some principal stresses will be induced in the component. Some components are subjected to torsion loads and bending loads. So, due to this combination of these two loads, some principal stresses will be induced in the component with shear stresses. So, how to solve those type of problems today we will see. So, take example, the shafts like crankshafts in an IC engine are subjected to torsion loads and the bending loads. So, in this case, the maximum principal stress will be occurred due to this combination of tensile or compressive stresses with shear stresses. Those type of stresses will be calculated by using some equations. The first one is the maximum tensile stress. In this equation, see, the maximum tensile stress due to direct load or bending load, we can represent with sigma T. The sigma T maximum is equal to sigma T by 2 plus half into square root of sigma T whole square plus 4 tau square. Here, the sigma T indicates tensile stress due to direct load and the bending load. And tau is shear stress due to torsion. So, whenever the component or a machine member subjected to these two loads, so either it may be tensile stress or the compressive stress or torsion loads, these type of principal stresses will be occurred. At that time, you have to find the maximum tensile stress or maximum compressive stress or maximum shear stress. So that's why these whatever here framed the equations will be useful for problem solving. The second one is maximum compressive stress. Here the component is subjected to direct compressive stress or compressive load. So sigma c by 2 plus half multiply with square root of sigma c square plus 4 tau square. Here sigma c is compressive stress. The stress will be occurred due to the compressive load. The tensile stress will be occurred due to the tensile load. Similarly, the maximum shear stress. So shear stress will be occurred due to torsion. The tau maximum is equal to half multiply with the square root of sigma t square plus 4 tau square. So now we will see how to solve these type of problems whenever the component subjected to combined loads. See, the given problem, the hollow shaft problem. So here some data given. A hollow shaft of 40 mm outer diameter and 25 mm inner diameter. It is subjected to a twisting moment of 120 Newton meter. Simultaneously, it is subjected to axial thrust of 10 kilonewtons and a bending moment of 80 Newton meter. See, here the hollow shaft of having diameter, outer diameter is 40 mm and inner diameter is 25 mm. Clear? It is subjected to a twisting moment, torsion, 120 Newton meter. And as well as the axial thrust of 10 kilonewtons and a bending moment also acting. So 80 Newton meters. So see here, one is direct load, direct stress, another one is torsion, other one is bending. Here the combined stresses are acting on a hollow shaft. Calculate the maximum compressive and shear stress. Here he has asked, calculate the maximum compressive stress and shear stress. What is the maximum stress and what is the maximum shear stress? When the hollow shaft is subjected to combined loads or combined stresses. So how to solve this type of problem? By using whatever we have learned in equation, first session equations we have to apply for this problem. So first of all, for any design problem, have to note down the given data. So first given data, D naught 40 mm, DI 25 mm, and torsion 120 Newton meter. You can convert into Newton mm, and then load. The axial thrust load is 10 kilonewtons, and this load also convert into newtons, and the bending moment is 80 Newton meter. So first you have to calculate the cross-sectional area of the shaft. The cross-sectional area of the shaft is generally for solid shaft is 5 by 4 d square. But here given shaft is a hollow shaft. So that apply this formula 5 by 4 multiply with d naught square minus di square. So d naught is here outer dia. Di is inner dia. So substitute the given values in this equation, you will get the cross-sectional area of the shaft. So that is 766 mm square. Now calculate compressive stress, direct compressive stress. So why? Because here the axial thrust, the direct axial thrust load is given. That is P, 10 kilonewtons. So now calculate compressive stress, sigma C, load upon area, cross-sectional area of the shaft. The given load is 10 kilonewtons, and the area already we have calculated, the cross-sectional area of the shaft. So substitute those values in this equation, you will get direct compressive stress. That is 13.05 megapascal. And find out the section modulus of the shaft. Z is equal to 5 by 32 d naught to the power of 4 minus di to the power of 4 upon by d naught. So this is for hollow shaft. In the case of solid shaft, Z is equal to 5 by 32 d to the power of 4. Z is equal to 5 by 32 d to the power of 4. But given the shaft is hollow shaft, that's why have to use outer diameter and inner diameter. So calculate the section modulus. So we have calculated direct compressive stress and section modulus. Now find out bending stress due to the bending moment. So bending moment, the shaft is subjected to bending moment. Some value is given in our problem. So that's why, so the bending stress will be induced in the shaft. So calculate the bending stress sigma b by using this empirical relation m by z. So m here bending moment and z is section modulus. So substitute. So calculated values, you will get 15.02 megapascal. This is compressive. So what is the total resultant compressive stress stress acting on a shaft? One is due to the direct compressive load, the axial thrust load. So that is sigma c. So compressive stress is sigma c. And another one is due to the bending, the movement, the bending stress. So that also the nature of the bending stress is compressive. So total, the resultant compressive stress is sigma c is equal to sigma b plus sigma naught. So that is the sum of these two. So we will get 28.07 megapascal. Now apply the torsion formula. So T is equal to twisting moment is equal to 5 by 16 into tau multiply with so d naught to the power of 4 minus di to the power of 4 by d naught. So this is the torsion the equation generally for solid shaft is 5 by T is equal to 5 by 16 multiply with the shear stress multiply with the dq. In case of a solid shaft. But here the given shaft is hollow shafts. That's why in place of D have to use outer diameter and inner diameter. In our problem has given D naught and Di. So substitute those values. You will get tau value. So we don't know the shear stress not available. So how to find the shear stress value. Now the maximum compressive stress and maximum shear stress have to calculate. The maximum compressive stress, the formula is sigma c by 2 plus half of sigma c square root of sigma c square plus 4 tau square. So why should we calculate the maximum compressive stress? Here torsion load and bending load and the direct compressive load the acting on a shaft. So the combined stresses. So due to these loads, so always some principal stresses will be occurred. So that's why we need to calculate the maximum compressive stress and maximum shear stress by using principal stresses empirical relations. So substitute those values in this equation. You will get 32.035 megapascal will get. So similarly, the maximum shear stress. So what is the formula for maximum shear stress? Half of sigma square root of sigma c square plus 4 tau square. Okay. The sigma c value already we have calculated, that is compressive stress, that is total resultant compressive stress, and tau value the shear stress. So we'll get the maximum shear stress and maximum compressive stress we'll get. So whenever the shaft or component are subjected to combined loads, so we need to calculate like this. So these are the differences. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.